So now in the IBDP portion of the of the fuel cells, we have to we have to get to know that why do we use fuel cell? There's a fuel cell which you're having, and this fuel cell will be the next important cell which will be used, right? Because the petrol reserves are getting down, the all the coal reserves are getting down. So and also there's a huge risk of the global warming coming up because this, carbon dioxide is emitted. If you see, when we talk about this reaction which happens in a fuel cell, hydrogen and oxygen, they combine to give you H2O. So this is a very important reaction, but the main focus we have to give on the products which are getting. If you take petrol or diesel, I'm writing this writing the equation CXHY OZ plus oxygen gives you CO2 plus H2O plus energy. So this is very important that when we see that in any reaction, you'll be seeing that the petrol or the diesel or the aviation fuel, they will be releasing carbon dioxide. This is the main cause we have to worry about, because this is a greenhouse gas, and this will be emitting they'll be increasing the greenhouse gases, causing our temperature of the earth to increase. So we have to make sure that we have to save our mother earth. How do we do it? There's a very good alternate which you're having. The alternate is what? The hydrogen combustion. Hydrogen combustion gives you only one product. Can you see this? That is also safe, water. We're getting water. Now this water is very safe, right? So it will be not harming our mother earth, because carbon dioxide is emitted by all the other particular modes of transport we are doing, right? Excepting electric cars, right? Hmm. Now this reaction gives almost, you will be shocked to hear this, almost 20 to 30 times the more energy than a petrol car or a diesel car gives. Isn't it very, very important and interesting? But why don't we grab this and we start producing the fuel cell cars? So that's a question mark. Why aren't we doing it in a faster pace? There are causes for it. The first cause is that we're trying to save the mother earth by trying to reduce the carbon dioxide emission which is coming from that from the greenhouse gases, isn't it? Now on the other hand, we are seeing that hydrogen which we are sourcing over here, where do you source hydrogen from? We source hydrogen from the electrolysis of water. We learned this in our electrolysis chapter. Electrolysis of water, we source the hydrogen form. This reaction happens. H2O gives you H2 plus O2, right? But over here we have to use lots of electricity. Electrolysis needs lots of electricity, isn't it? You need lots of electricity.
Yes.
And electricity is mainly coming from where? Mainly coming from burning of coal. This coal will be giving off what? This coal will be giving off sulfur dioxide, carbon dioxide, right? Carbon dioxide is okay. It's a safe gas, but it's a global warming gas. But sulfur dioxide, coal contains lots of sulfur content. When the sulfur burns, the sulfur dioxide forms or sulfur trioxide form. So when sulfur dioxide mixes with water in the clouds, what it gives is to gives you H2SO3 and H2SO4. See, acid. So we get acid rain. So on the one hand, we are seeing that what are the challenges of this? The main challenges of why we are not hurriedly proceeding on. The most important challenges is that we have to find out ways by which we can generate the hydrogen from water in a cleaner way. This hydrogen is sourced from where? This source of water, right? Mainly now. We have to think that what are the other ways, other easiest ways by which we can source this hydrogen from, right? Because we
Mm-hmm.
use electricity now in electrolysis of water. Now, what the second important hurdle? The second important hurdle will be very important for us. That hydrogen is a very, very inflammable gas. It's very difficult to store and transport. Is it clear? It's very difficult to store and
Yes.
transport. So that's a very important point we have to master. Hydrogen is a very difficult gas. It's a very difficult gas to store and transport. So that's a very important point we have to master. That whenever we are seeing the hydrogen is a very difficult gas to store and transport. It's very inflammable. So that's the reason we have to make sure that the storage facility and the transportation facility is very, very difficult to do. So that's the reason why we are having. But yes, there are cars which are there which are running on this fuel cell, this important reaction. Only water is given as a product. You will be seeing that Toyota has launched the cars in India also. In Germany, there are buses which are running on hydrogen fuel. So this is the next generation part. Now Now this reaction will be happening what? This reaction will be happening in a fuel cell. Now what happens, you see, you will be getting this advantage and the disadvantage of it. We'll be coming to this part. Now how does the setup looks like? The setup looks like in the fuel cell, in the hydrogen fuel cell, the setup looks something like this. We are taking we are taking the hydrogen. We have to take the hydrogen plus oxygen gives you H2O, and huge amount of heat and energy is liberated, right? Now over here we have to learn that when we take hydrogen, we are taking hydrogen from the cylinder. We are taking a cylinder, we are pumping in hydrogen. Which part we are doing? Here you have to remember that we are pumping over here at the anode, right? Always remember. We learned that cathode reduction happens, right? Cathode reduction happens in any cell, in voltaic cell or electric cell, cathode reduction happens. And anode, what happens? Oxidation happens. So hydrogen does what? This is a very important part. How the setup looks like? The setup looks something like this. We have got two tanks, and we have taken what? We have taken a special kind of electrode made up of carbon, right? The special kind of electrode. I'll be telling you why it is special. Now, we are taking two electrodes over here, anode and the cathode. In between, we are taking what? We are taking a proton exchange membrane, right? This. We're taking a proton exchange membrane. What does the proton exchange membrane do? This proton exchange membrane will be selectively allowing some ions to pass through. This is a very important part. We're taking a proton exchange membrane, and we are taking a electrode over here, cathode. We are taking anode over here. Now we have to now see that we are taking in hydrogen over here. Oxygen, what we are doing? Oxygen we are pumping in from the anode. This part is very crucial. Anode. Sorry, the cathode. My bad. It was my bad, right? So cathode, we are pumping in the cathode, because cathode, what happens? Oxidation. Reduction happens. So we are taking oxygen from where? From the air, and hydrogen from the hydrogen fuel cells. We are taking, right? Sorry, from the cylinder. And if you see the reaction at the anode, what happens? Hydrogen will be giving off 2H plus 2 electrons. See, 2 electrons. Now the important trick which are using this electrodes which are using, this electrode won't allow the electrons to cross over. This part you have to learn. Won't allow the electrons to cross over and move to over here. It won't. So the electrons will be forced to move in this direction. What we do? We join with a wire, and we put up. Suppose we are putting an electric motor, a car motor or a bus motor, right? Or a scooter motor or a bike motor over here. So this is very important, that what happens at the anode. Anode, the hydrogen gas is pumped to the cylinders, and we get 2H plus 2E. These 2 electrons will be carrying by the electrical circuit and reaching the cathode. In the cathode, what we are pumping in the cathode, we are deliberately pumping air. What is air? Oxygen. Air contains oxygen, right? So oxygen will be linking up with these 4 electrons, plus what happens? The H plus which is generated over here at the anode, this will be helped by the proton exchange membrane to selectively diffuse to the cathode. Is it clear to you what the proton exchange membrane does? Proton exchange membrane will be allowing only H plus ions to travel through it. It won't allow the electrons which is generated in the anode to pass through it. This is clear? So this is a proton exchange membrane which is allowing the H plus ions which is generated at the anode move towards the cathode. Is it clear? Move to the cathode. So that's a very important point to master, right? Isn't it? So this is very important, that whenever we are seeing that oxygen will be linking up with the H plus ions which is coming from the anode, and the electrons come from where? From the wire. Flow of electrons is electricity. So we are getting what? We are getting the generation of the electricity over here. And these 4 electrons will be coming to the cathode, and oxygen plus 4E plus 4H plus gives you 2H2. See the product? We are getting what? We are getting the waste product as water. So if you are joining these two, if you are adding these two reactions at the anode and the cathode, we have to balance the electrons first. We learned earlier. What we do? We multiply this by 2. And multiply this by 2, the electrons gets balanced, because we have to balance the electrons over here. Simple, right? So we multiply this by 2, we're getting 2 over here plus H plus 4E, and adding these reactions. So 4E gets cancelled out, 4H plus gets cancelled out. And what is the overall equation we're getting? 2H2 plus O2 gives you 2H2. See, a safer product you're getting. So this was all the description of what? This was all the description of the hydrogen fuel cell. Now we move on to the part which comes in a board exams, that what are the advantages and disadvantages of this. As I've told you, that the hydrogen fuel cell is depending upon hydrogen, right? Hydrogen is still obtained by electrolysis of water, and electrolysis of water needs what? Needs electricity. This is the electrolysis of water. We have to get hydrogen. See, in electricity of the water, in the electrolysis of this water, we use electricity. And where does the electricity come from? The electricity comes from the coal burning, right? It comes from the coal burning. Understood? Fine. See, it is a renewable, it is a non-renewable source of energy, and it also releases sulfur dioxide, carbon dioxide, right? Now, what are the other options to get this H2? The hydrogen which we get is also obtained from steam reforming of hydrocarbons. This will be coming in exams in the paper 1B also, right? So this is a very important topic which can get marks, right, easily. So how do you do steam particular reforming? In the steam reforming, hydrocarbons such as natural gas, if you take, right, or gasified coal or biomass or diesel or other liquefied particular fuels, right, we take and we undergo steam reforming. How do they do it? Over here, we take the hydrocarbon and we add steam to it. What's the reaction given? Carbon monoxide plus hydrogen. See, hydrogen we are getting over here. This we are getting to be used in the fuel cell. Now, you have to remember that this carbon monoxide is a lethal gas. It causes death. In the next step, this is a wonderful reaction. See, in the next step, you are seeing what? In the next step, this carbon monoxide will be reacting with the H2O steam, because H2O steam, is it clear? We take CnH2n plus 2 and we are adding what? Steam, water in the form of steam in a chamber. So this gives you carbon monoxide plus H2. The carbon monoxide which is formed will be reacting with the enormous amount of the steam which is there in the system and giving what? Carbon dioxide plus hydrogen. So see, carbon monoxide is a lethal gas. It is converted to carbon dioxide and we are getting hydrogen which is there. So this is very important, that if you see that this process is okay, but ultimately, can you see this? This gives you carbon dioxide, right, which is a greenhouse gas. So we have to search for newer sources of hydrogen. That's the challenge we have seen, right? We search for near sources of hydrogen, cleaner, greener sources of hydrogen gas. So that was what that was all about. That was all about the hydrogen fuel cell. Right, before ending the topic, we have to go to that part of the advantages and disadvantages of the hydrogen fuel cell. What are the advantages of the hydrogen fuel cell? The advantage of the hydrogen fuel cell is that no pollutants is produced. See, water is produced only.
Yeah.
It can be of different ranges and on sizes. We can use it in a scooty or on a motorbike, or we can use it in a truck also. We can use it in an aircraft also. They don't need to be electrically recharged, isn't it? Everybody is going for electric cars now, but nobody knows that. Few people know that electric cars, where is the electricity coming from? Where they're recharging the cars? Electricity is coming still now from burning of coal. See, a fossil fuel. So in the electric car, you have to recharge it. In the hydrogen fuel cell, we don't have to electrically recharge. What are the disadvantages? As I discussed to you, the most important disadvantage is this. First thing, hydrogen is very difficult to store and transport. Hydrogen is very highly inflammable. A small spark can give a huge blast to the entire setup. Is it clear? And hydrogen is sometimes produced for the cell by non-renewable sources. Yeah, not sometimes, right? Not sometimes. Mainly we are getting hydrogen from what? The electrolysis of water, as I've discussed to you, right? This electrolysis of this water will be needing coal to generate electricity. So these are the reasons which you are seeing over. See, in the hydrogen fuel cell described above, which gases are pumped in the fuel cell? So we pump hydrogen, and we pump hydrogen and the anode, right? Anode. We pump air. Air is what? Oxygen, right? In the cathode, right? What are the waste product of the fuel cell? Water is the waste product we are getting, right? Write a word equation for the overall reaction of the fuel cell. We can write out hydrogen plus oxygen gives you H2O. So this is very important. Write down the two half equations and show what happens if the hydrogen and oxygen gases in the fuel cell. It's a very good question. So the two half equations we have to master over here. That's the important part. The first reaction is
Yeah.
what? The first reaction is that hydrogen will be giving you H plus plus 2E. This H plus will be traveling via the proton exchange membrane. We are very deliberately and cleverly taking the proton exchange membrane, which does not allow the electrons to pass through, only allows hydrogen ion to pass through and reaches the cathode, and the electrons will be forced to go via wire and generate electricity. and this will be getting reduced at the cathode. So oxygen reduction is happening to 4 plus 4e plus 4h plus gives you H2, 2H2. So this was all about what? This was all about the fuel, hydrogen fuel cell we are taking. In the next video, we'll be going over that. What are the other alternatives of the cells which are using, right? Thank you so much. Thank you so much for watching.